Welcome to my channel Fundamental of Pharmacy class. Today in this video I would like to discuss principle of column chromatography. So before discussing that I would like to discuss two things. One is adsorption, another one is absorption. What is adsorption? Suppose we consider a football and which which was just touched a water level. What will happen? The water will touch the just only the surface, it will not enter inside. Okay, so this phenomena, absorption of water in the surface, is called adsorption. Okay, you take another example. Suppose a piece of sponge, if you dissolve if you touch in water, then what will happen? This water will absorb throughout the whole surface and inside of this material. This is called absorption. So absorption is a whole phenomena and adsorption is a surface phenomena. In another one, that is partition coefficient. What is that? When a solute, take this example, suppose C6H5 CH2OH. So this is a compound solute. If you dissolve this one in two immiscible solvent, that means in water phase and oil phase, then what will happen? This polar non-polar part will dissolve in oil phase and the polar part will dissolve in aqueous phase, that means water. Now the concentration of this substance C6H5CH2OH, the concentration in oil phase and concentration in water phase, that ratio is called partition coefficient. Next coming, hydrophilic and hydrophobic. Hydrophilic means, hydro means water and philic means loving, that means water loving compound, which is generally polar, we used to say. Now lipophilic, it is composed of two words. Lipo means lipid or oil and philic means loving. So this is, we usually note it as non-polar. Now coming to the point, column chromatography. You see, this is the column, whereas the stationary phase, you consider this is adsorption chromatography. Okay, that means the solid phase is stationary phase is solid and the mobile phase is liquid. Mobile phase is liquid and stationary phase is solid. Okay, now you see, if it is silica gel, which is polar in case of normal phase chromatography, so here the stationary phase is there and above that there is mixture of compound. Now this silica gel is polar in nature. Now compound may be polar and mixture of polar and non-polar. Now thing is that your mobile phase, suppose it is non-polar. If it is stationary phase is polar, then mobile phase would be non-polar. Now if you put mobile phase here, due to gravitation it will come down. So when it will come down, your compound may be polar and non-polar mixture. The polar compound, consider your compound which is polar in nature, having affinity towards polar system, that means silica gel, so it will stick here in the above part. Okay, now we consider non-polar compound, that is having low affinity towards stationary phase and having high affinity towards this mobile phase, as it is non-polar. So this non-polar compound having high affinity towards mobile phase and low affinity towards polar stationary phase, so it will elute fast. So here you will get non-polar compound, then accordingly you will get increase in polarity. Now thing is that mobile phase may be this separation may be isocratic, may be gradient. What do you mean by isocratic? Iso means same, cratic means the polarity. When using same solvent again and again, that is called isocratic separation. Suppose you are using ethyl acetate, and again you are using ethyl acetate again and again. So this is called isocratic gradation. Now if you consider gradient separation, that means you are using solvent and you are changing again. Suppose you are starting with benzene, then you are changing to ethyl acetate, okay, then you are changing, suppose acetone, like this way. So changing of polarity. So this kind of separation is called gradient separation. Now we consider another one chromatography, that is partition chromatography. Here I have already mentioned partition coefficient due to different in solubility in oil phase and water phase, that compound gets distributed in both the phases. Now you see, if your stationary phase is mobile phase, stationary phase and mobile phase both are liquid in nature, so that time partition coefficient is applied. So it will be called a partition coefficient. Now you as like previous example, suppose your mobile phase is non-polar and stationary phase is polar. So which is having polar compound having high affinity towards polar stationary phase, so it will stick here, okay. Having low affinity towards non-polar and having highest more affinity towards polar stationary phase, so it will remain here. So movement is slow. Now we consider non-polar compound having affinity towards non-polar solvent, so it will move faster, and having low affinity towards polar system, so this is low and this is high, so that's why it will elute faster, and first compound you will get non-polar compound. So depending on your choice, whether you want to separate non-polar compound or polar compound, accordingly you have to choose the chromatography. In both the cases I have mentioned that non-polar compound will separate fast, so in this case this is called normal chromatography. Normal chromatography, okay. So if you want to if you want to separate polar compound fast, then reverse phase chromatography can be used, okay. So if you have any question, please comment in the comment box. Thank you. And if you do not subscribe our channel, please subscribe it. Thank you very much.